Welcome, viewers and subscribers. Welcome back to the channel. Welcome back to another video. Big up on yourself, large up on yourself. For those of you who have subscribed, especially for my new subscribers, I thank you very much and enough respect to that. Now, today I'm going to talk to you about something different, a different type of construction. So I'm going to talk to you about road construction, or otherwise known as pavement construction. I have been speaking to you about predominantly about building construction, so I've pretty much exhausted that topic. So I'm going to move now to some different topics. I'm going to talk about road construction in this video. The next video I might talk about retaining structures and so on. So therefore, it might come to you as a surprise that my main area of focus is civil engineering as it relates to transportation engineering and road construction. I have majority of my experience is in road construction, not building construction, road construction. So I've done a lot of road work back in Jamaica, working for the Ministry of Local Government and Works, and also working for the National Works Agency. So in this video, I'm going to show you how a pavement is designed, the different types of pavement, and the significance of pavement construction in our country. As you know, bad roads in Jamaica is a big issue. Every time you watch the news, people are protesting that they want better roads. So we're going to shed some light on that also. If I can't cover everything in this video, I'm going to do another video to see if I can do a more comprehensive analysis on what goes on in road construction and how we can build better roads to facilitate our growing population. So stay tuned for the video. Don't go away. When it comes to pavement design, there are two different types of pavements. There are flexible pavement and there are rigid pavement. In flexible pavement is a layer system that is consists of the subgrade, which is known as the natural ground or the foundation of the pavement. Then there is the subbase, there is the base, and there is the wearing surface. In rigid pavements, it is mainly the subgrade on a concrete slab, right? And at times, you might have a wearing surface that is placed over that concrete slab. So I'm going to show you the different layer system of each of these pavements and explain to you the different function of these layers as it relates to flexible and rigid pavement. So I'm going to start by looking at flexible pavement. So what we have here is a cross section of a flexible pavement. So we have the subgrade, we have the subbase, we have the base, and we have the wearing course. So let me explain to you the significance of each of these terms. So the subgrade is the natural ground on which the pavement is constructed, and it forms the foundation of the pavement. So similarly to when we are constructing a building or any structure, the foundation, as you know already, plays the most important part. So the subgrade is there to carry the stresses of the pavement. Now, immediately above the subgrade, we have the subbase. And the subbase carries two functions. It serves as a drainage system for the pavement itself, and it's also used to strengthen the subgrade. So in instances when you have a weak subgrade, you usually the engineer usually introduce a subbase to strengthen the subgrade so that the pavement have adequate bearing capacity to carry the traffic load. Now, the base is what forms the modulus of rigidity of the pavement. So what the base does, the base carries the load or the traffic load or the fatigue or the stress of the pavement. And it is usually constructed with high quality material. So oftentimes we use marl and we ensure that the quarry that we're taking the marl from is being tested and the marl is good enough to form the base of the pavement. Because if the base is not good, the structure is not going to last. And it also used to spread the traffic load evenly through the various layers down to the subgrade or the foundation of the pavement. Then we have the wearing course. So the wearing course is what we use to provide a smooth surface for the pavement, right? So the wearing course is usually made up of high quality material. It can be bituminous material and it can be asphaltic concrete. So that is pretty much what the layer system is for the subbase. Then we have the subbase, the thickness, it ranges from 4 inches to 10 inches. Same thing with the base. And the wearing course ranges from 2 inches to 4 inches. So that pretty much is, in a nutshell, is what the flexible pavement consists of. Before I move on to explain to you what rigid pavement is all about, there's something important I want to add to the flexible pavement, and that's the thickness of your layer structure is dependent on the structure number. So what the engineer does, the engineer calculate the structure number, goes to a chart, and he can get the thickness of the different layer dependent on the structure number. So these dimensions here are all minimum dimension. They're 4 to 10 inches of your base and sub-base, they are just minimum dimension. Also, I want to point out that the overall thickness of your layer system of the pavement is dependent on the strength or the bearing capacity of the subgrade or the natural ground on which the pavement is going to be constructed. So the weaker your subgrade, the thicker your pavement. The stronger your subgrade, the less thickness you can design your pavement structure of. So always remember, and most of the problem that we have in our country in terms of our roads not standing up is because of weak foundation, weak subgrade. So the subgrade, as I said to you before, it is the strength it is the strength of the pavement itself. So one way how you can verify or you can know the strength of the subgrade, you have to carry out what is called a CBR test, the California Bearing Ratio Test. It's a test that was formulated in California in the United States to remove samples, soil samples from the sites where the pavement is going to be constructed, taken to the lab, and they carry out several tests to come up with the bearing ratio and as a result the strength of the subgrade. So for those of you who are watching the video, if you want to know what the California bearing ratio is and how and what goes on in the concrete lab or in the lab, in the soils lab, you can just punch in California bearing ratio in YouTube and it can show you the different procedures that goes on in the soils lab to come up with the soils bearing capacity. So that is a critical piece of information I wanted to add before I move on to explain to you what rigid pavement is all about. This is a formula here on how to calculate the structural number for your pavement. So the structural number is equal to A1, D1, plus A2, D2, M2, plus A3, D3, M3, and so on. So it is dependent on how much layer system you have in that particular pavement design. So where A is equal to the layer coefficient. So depending on the type of material that you're using for a particular layer, that material has a coefficient. So if you're using river shingle, or you're using marl, or you're using gravel, that particular material has a coefficient, and it is taken from a geotechnical chart, and you can get those values from that geotechnical chart, and you know your layer coefficient for each layer. The D is the thickness of your layer in inches. So as I showed you before, the thickness of your sub base, the thickness of your base, the range from 4 to 10 inches and so on, depending on what thickness the engineer decide to use for that particular layer. So, and then MI is the drainage coefficient. So as I mentioned to you before, the sub base, the material that you use for your sub base in order to strengthen your subgrade, it is also a drainage system for the pavement. So on each layer they have a drainage coefficient, because what you want to achieve when you're doing your pavement design is that you have layers that can easily drain away water. You do not want water to settle on the pavement, and you do not want the water to settle in between layers, because over time, when the vehicle loads start to penetrate the pavement, when the cyclic loads start to penetrate the pavement and the pavement becomes fatigued, that is how you're going to have potholes forming in your pavement. So that is another piece of information that is pertinent to this video. Rigid pavement. In rigid pavement, you do not have as much layer system as in the case of a flexible pavement. So rigid pavement is just the base and the concrete slab that is placed on top of the base. In instances where you have a strong subgrade or a strong foundation for your pavement, you do not have to introduce a base. You can just simply put the concrete slab over the natural ground if the natural ground is of such that it can drain away water, or it can be of good strength to form the strength of your pavement. As I said in numerous times in this video, the strength of your pavement is dependent on the strength of your subgrade or the strength of the natural ground. It forms the foundation for the pavement. I can't repeat that often enough, because it is very important and we need to understand this. Okay? A road structure is not different from a building or any structure. It is a structural element and it carries load, and therefore the foundation have to be of such that it is strong enough to carry whatever load that pavement or structure is being influenced by. So we have here this cross section of the rigid pavement here. So we have the subgrade, which is the natural ground or the soil, the subbase. As I said, let me reiterate that the base at times is used to strengthen the subgrade. So when you have a weak subgrade, you normally introduce a base to strengthen the subgrade, right? And on top of the base, we have the concrete slab itself. So we have the base, which ranges from 4 to 10 inch, and the slab, which ranges from 8 to 10 inches. So all I'm saying, those are those minimum dimension. It can be more. It depends on the cyclic load or the fatigue or the stress that that pavement is going to undertake. So if that pavement structure is going to be subjected to high traffic, to heavy traffic, the thicker the thicker the layer system is going to be. So as you can see here, we have what is called a dowel transfer bar and a contraction and expansion joint. So the reason for that, you will know that concrete, when you have extreme temperatures, when you have high temperatures, particularly in the summer months, your concrete is going to expose to a lot of heat and it's going to expand. So just as in the case of any object, anything that comes under high temperature, heat, it is going to expand. So because of that expansion, the concrete surface has to have a gap to allow for that expansion. If there's no expansion joints in the concrete, when it heats and it's going to expand in its volumetric dimension, the expansion has nowhere to go because there's no allowance for the expansion, and henceforth your concrete is going to end up with structural cracks, and that is going to be hazardous for the traffic that is using the pavement, and it's going to cause problem for your maintenance cost. Your maintenance cost to maintain the pavement is going to go up, and you do not want that. And you do not want, most of all, to create unnecessary hazard for the traveling public, because that can be catastrophic and it can also be fatal. So that is why the most of the time you see in your concrete pavement an expansion and contraction joint. Also too, you want, when the concrete is heated and and the temperature start to reduce, it start to get cooler and cooler, it's going to contract. And you do not want it to contract past its original volumetric dimension. So that is why the contraction and the expansion joint is critical in your rigid pavement, right? So as I said to you before, rigid pavement is just a concrete slab that is placed over the subgrade or placed over a base material. So in terms of reliability, I don't know which is better. I was told by an engineer before that concrete pavement lasts more and the maintenance is much more less. So that is a critical piece of information that I want. But also I want to point out, based on my experience here, working on a bridge, when we do a concrete deck, a concrete surface always poses a lot of noise. So that is a negative when it comes to the concrete pavement. The noise pollution is very heavy, and they always have to put up sound barriers along the corridor to cut down on the noise pollution, especially at nights, when sound travel at nights more because there's less sound to cancel out the sound from the pavement. So that is also a point I want to point out, that the noise pollution from the concrete is very high, and oftentimes we usually have to put up a wall as a sound barrier to limit the noise to transmit all over the environment that is going to disturb schools, hospital, or even people in their own homes. So I have come to the end of this video. If you like the video, hit the like button. If you're a new time subscriber to the channel, I really appreciate it. And if you have watched the video to this far, I'm asking you to watch the ads as well. Okay? Thank you, and I'm going to catch you in another video upload. Enough respect.